start with showing you this website for sample projects that are provided by Google itself, that is through the developer website. So just in case you're looking for some components that you wish to try, or you want to learn something, you can always come here. And it's as easy as selecting a language you prefer, and then you select a component you would like to look at. And so if I try to select storage, and you can see some content providers here, there's also media store. So if I just tap on media store, then I can I can be able to get to GitHub, and GitHub will show you what the project is about and what demonstrates the SDK used, and they will show you how it looks like if you run it. That is more like a gallery. And so if you're interested in search, you can easily just download the project and use it. So all these projects are there. They are free. You want to use, know how to use files. The content providers are also here, different languages. And they are saying this demonstrates it with paging. It also, because the paging was introduced in Android O, so you can feel free to access these projects and, well, try them or pick some components that you might need to learn from. And of course, nothing stops you from extending from these projects, starting with some of those sample codes and then going ahead to customize them and build them as you prefer. Of course, at this point, the challenge would be how do you incorporate the components that you built already last week. But if you can do that and incorporate what we did in the first homework, then you can use any sample that's already existing. Of course, usually the challenge is how do you understand what was written in that sample. Everything starts from there, and once you understand it, then you're good to go. Then also there are code labs. So the other ones were more of sample projects. So assuming you already know something, and then you just want a sample project to start from, you know that you can easily go through the code and understand what the project is all about. But then the code labs here are more tutorials. So they are meant to teach you on how to go through different building different Android applications. And so we have seen that the applications we are building can run on a phone, that is a smartphone, and a tablet. Those are the applications we have built. But also, you can build applications to run on smartwatches. And for smartwatches, there's this section of wearables. So here you can build for your wearable smartwatch, so long as it's running the Android operating system. Okay. And this is basically devices here and so on and so forth. So you can always come to these projects and see how they are and choose. Even if you want to do some courses, even the courses are there. Okay, from Android basics to this Jetpack Compose, it's very interesting. It takes away a lot of tough or heavy work. Then also now they introduce this Compose with Firebase. So in case you're interested in learning about that and you're saying this is Compose with. Compose is basically a better way of building user interfaces. As you can see today, when you're trying to add a button to your project, you have to first go in XML, add a button, then you go to Java, say find view by ID, then you look for a button, connect to it, and so on and so forth. So Compose is one of the libraries that was introduced in the Jetpack toolkit that can reduce a lot of such processes by making it less rigorous and also reducing still on the code that you need to write. So here they will introduce you to Firebase, building the app UI, and they take you, of course, step by step, material design or adding Firebase to Android. So yeah, if you just choose this project, building Android with Jetpack, that was, it has 9 activities. That's the whole project. So feel free to explore some of these options. And let's see, adding Firebase to Android. So you have to go through 9 tutorials. So from the introduction here, then there are videos, and these are videos that have been released by.
Why do we have to talk about architecture before going to the exercise? Well, according to Robert C. Martin, the author of Clean Architecture book, the architecture of a software system is the shape given to that system by those who build it. And when he talks about shape, he's talking about.
So there's authentication here, Firestore, saying how to add it to your application. It's all this is about storage, routines, and so on and so forth. So you can follow through and try to see how to utilize the different components. Okay, that is Compose. So some of these steps, anyway, you have already done them. But the idea was just to introduce you to these projects such that at any one point, if you need them, you can go and expand on your knowledge. Yeah. Yeah. This we had started databases yesterday, and we had stopped somewhere. So to remind us, we talked a lot about SQLite, and we said that that is a database where we store information. If I may ask, how many of you have worked with databases on mobile? If you have ever worked with any database on mobile. You have? Okay. I have it. And the rest? Patrick, Anthony, yes, Joshua.
I haven't.
Yeah, I've used Postgres before.
You've used Postgres. Okay.
I think I was using, I think of recent, I just used SQLite.
Okay. For mobile or for web?
Mobile, then web, MySQL.
Okay. SQLite and MySQL, but they are two different database management systems, though. Or you used SQL in SQLite?
Yes, sorry. SQL,
Okay.
then SQLite in mobile.
Okay. I saw Stella. Stella, you wanted to say something?
No, doctors, just responding to the question that I have not yet worked with it.
Oh, okay. That's fine. Then, so when you look at your projects, what would you want to store in a database? Because of you have different projects. So what do you think you would need to store in a database? Can I start with you? Okay. Baluku, did you want to say something or just joined anyway? It's okay. So I was asking for your projects that you're working on, what would you want to store in a database? I mean, it can be online, it can be, you can store in files, that is locally. You can store in the database itself. You can store on the memory card. So what kind of information or type of information would you wish to store? Yes, Patrick.
Yes, doctor. I think to me, I prefer storing text information in database. Then for media, I just I store the reference. I don't know, my internet I think went off, but I was saying I prefer storing text data in the database and maybe the reference of media as well in the database. Then folders, sorry, in directory, that is where I prefer storing the media. So basically, I prefer text in the database. Thank you.
Okay, so, but in regards to your project, what exactly would you store? Patrick, I was still listening to you.
In regards to our Medic Connect project, I would have to store the information related to doctors. You realize we had doctors and their photos will be stored in a directory. Then we shall have to as well store the patient history. That is also text format. And then basically that is it. Then for the purposes of self-diagnosing, we shall have to use a powered AI. I think that one may also require data directly, in the database. So for me, I currently have not conceptualized the whole everything regarding the development. Basically, we had that idea. But I think when I sit with my colleague, we shall explore more of the structure that will be organized in the database.
Okay. Thank you, Patrick. Anyone else want to go next?
Yes, Doctor. I can just give what I think because we have not yet implemented, and I'm just giving maybe my thought.
That's okay.
Yes, considering our PPH predictor, I think basically the variables are best to be stored in the database. That is the age, the parity, maybe the HB of the mother, such that maybe for future, even after it would be good to go and reflect and find out maybe the final predictions and so on. But also maybe later for data analysis, it can help us maybe get always clinical reports, show some trends, and then also maybe for some feedback and so on. That's what I think.
Okay.
Maybe
Interesting.
my colleague can,
Sorry?
my colleague, Joshua, maybe you can supplement or say something about it, but that's what I think.
Yeah. I think you're on the right track. The patient risk data, like the name, age, parity, all those parameters, that the variables that we are dealing with, store them in a database. And then also after maybe calculating the risk, PPH risk, we would look at storing the prediction results, where we would have maybe like a prediction ID, the risk score, and the risk category, whether high or low, yeah, and maybe also storing users. If some users have logged in, so like the username and the role, whether this is a nurse or a midwife or a doctor. So, and also password, maybe hashing, the password hash can be stored if we maybe decide that we want to use offline login. Yeah.
Okay. Thank you for that feedback. And Anthony, what are we going to store from your side?
Yes, doctor. On our side, we're going to capture patient's data and doctor data. We have to now get the credentials from the doctors, their names, look at their bio information.
So, yes, I think I pick the idea now. And what is interesting is trying to figure out what to store in the database, and also. Oh, Anthony, you want to continue? Please do.
Yes. I was saying that in our teleconsultation application, we're going to capture user information where we shall be storing personal details, authentication data. We can also store payment information in case we integrate payments through the platform. Then we can also store medical history, the symptoms, because we have an AI symptom checker, so we can store those symptoms for future analysis. We can also have prescriptions, maybe we can, because it's going to support in diagnosis, we can store lab reports and scans. And then even consultation notes, in case we integrate our voice and video chats, we can also store the consultation notes. And then we also have the vitals and the health metrics. Yeah, and then since we shall have AI, so we shall have a chatbot interaction data. So those the user queries, the chat history, the feedback, and the decisions, the AI decisions that have been made by the model, we can also store that kind of information. Then since we are going to have appointments, you can also store appointment data, and then the video recordings, the messages that we shall have captured through the interaction between a doctor and the patient. Yeah, maybe security and compliance there. We can also have the access logs and the consent records as well, because we shall have also the security implementation on this application. So we can store the access logs and consent records. Yeah, I think for now, that's what we can now capture. For now, that's what we anticipate to store on the teleconsultation mobile application. Yeah, I submit, Doctor.
Thank you. That was detailed enough. And I think one of the things I notice here is to decide actually what to store in a database and not what to store. Because one of the ways in which this basically can be decided is if someone knows what exactly the AI is going to do. And that is also another big decision. So you have patient information, and let's say patients are entering this information. Do you decide that this is going to go through the AI because they won't need to store the information? Or do you decide that a part of this is going to be stored in the database? And then the other big decision that is usually made is do you store the information locally on your phone, or you store the information somewhere online? So some of the normal or basic standards, we usually store login or manage login credentials online. So if someone must log in using a username and password, then that is managed online. Then, because mobile applications are different from web systems, if you have multiple users, for mobile apps, we don't usually have that way where they all use the same application, and then when they log in, they access different information. For information systems, that is easy. So you have like a nurse, they log in, they access different information. You have a doctor, they log in, access different information. You have the IT person who is an administrator or a super administrator. Also, when they log in, they access a lot of information. Now, for mobile, it's different. Why? Because mobiles, we are limited in terms of resources when it comes to mobile. If you build an application that is too huge, and let's say someone requires 1 GB to install your application, then they will not use it. Because first of all, downloading will take time. Imagine downloading 1 GB of an application. Then after installing it, it's also taking a lot of space. And then the more you use the application is the more it keeps storing some temporary information. And so it uses up more space. A case in point is when you look at most of the social media applications. Of course, they are light as you download them. But when you use, let's say, WhatsApp for 1 year, if you check the storage it's taking, you will be surprised. You find it's using like 6 GB or 7 or even more, depending on how you interact, because all the texts and images and photos, they are usually stored locally. And even though you choose to store on the cloud sometimes also gets full, and then you must subscribe. So these are decisions that someone has to think about critically, depending on the type of data they have and the audience they are targeting or the users. So if you have different kinds of people who are going to use the application and they require different access or they require to access different information on your application, then you have to build different applications. What I mean is, if you want to build an application, mobile application, an installed application, and let's say you have a doctor and you have an IT person. These two, each of them, if they're going to access different information, each of them should have their own application. So that means we are building two applications. Remember, there's a time we're building a delivery application. I mean, you order and then we deliver. And one of the things we had to do was to build different applications for all our people. For instance, if we had, we were the administrators. So we as administrators had to have our own application. Then also the people who are building for, that is the users or the people who are going to access and use our application. They also had their own application. Then we had people in the market. So, you market, first we think about the market or a shop or suppliers. We also needed an application for them. Then the delivery, someone going to deliver. We also had to build an application for them. So these were like 4 applications because we had different users. Now, that's how the narrative changes when you're building for mobile applications. So if you want to build only one application, then you have to consider the fact that one is a user and then the other one can view from the website. That is either an information system also. So you have to build some sort of back end. So on the front end, you're showing us an application where users fill their information or patients fill their information. Then the information comes to the database. And then you have some sort of web system behind that is now viewed by the doctor also if they're in the hospital, because that's the assumption. You have patients in the field sending information, then you have a doctor seated somewhere in the hospital, and then he can see this information and it comes in through the application. But also if you want the doctor to use a mobile app, then you build a mobile app for the doctor. So I thought I would make that clear. But also in case you don't use Android, you could just build a web application. A web application. This now is more like a website. But of course it can be used on a mobile phone. So it's not entirely a mobile application. It's just a web application. So that one is also there. So I think the other part I need to mention is about let me just I need to explain something. Yeah.
Doctor, I think I have a small question on that.
Yes, please.
I'm sure I might be having less knowledge in mobile programming, but I've just tried a few projects. I'm wondering if you are designing different mobile applications for different users, a case to refer is patients and maybe doctors and then administrators that you are talking about, and you expect them to have relationships like communicating together. I don't know how that one would be dealt with in line with data or database. Like you said, in web it is very well controlled, where you can just manage the access privileges. So in mobile application, if you're having let me call them scattered application, how well do we manage that? I seem to get confused. I'm sorry.
I understand. I think that's why there are different levels of the application or any system. One, you have the front end, and that's usually the user interface. Then two, you have the it's not a back end, or where the level where you have the APIs. So basically, you're connecting the front end to the back end, which back end can be the database. Then you have the database itself. So you have the front end, then you have the back end here. But in between, you have an interface. Now, this interface is the one that basically interconnects the two. So on the front end, you can have a mobile app here. And then what it does basically is collect information. And through the interface here, it's sent to your database. It's sent to your database. Now, since you already have a database here, you can decide on how to share this information, because all information can be collected in a database. Even if you have a web somewhere, it can be a web interface, then still you can connect through the interface here and still store the same information in what? In the database. Now, the way you query determines how you want to supply this information. So you can say, okay, on the mobile, I only have patients. But you see, these patients are using the same what? The same database. Okay. Or you can say, okay, this is patients. Or then you can say for the doctors, they will be using the web. So you can still see they access the same database. But the part here I was trying to emphasize is that we cannot use the same mobile application and then distinguish between user types. So you have like user type 1 and then user type 2, where you have, let's say this is an admin, this is a patient, then you have number 3, who is a what? Doctor. We cannot do that on a mobile, except if you go in other ways. But you know, the problem here, I mean, why it is hard is that if it is a web system, everyone that logs in receives their independent application. when you log into a website or a web system as a patient, you receive specific user interfaces, like you have your own system. Then when a doctor logs in, they also have their own sort of system. That is for the web. Though it is the same system, it appears, but if you're a developer, you know it's like you build these pages differently. Everyone accesses their own information. Now, for mobile, that is not possible. Why? Because we are limited to resources. And I'm saying if you build an application that, let's say, allows 5 users to log into the same application, then the application has to be too big in terms of size, because you need different screens, you need different security protocols, because if someone logs in as a user or a patient, then there are things they can't access that are accessed only by the doctor. So that means you have to build security around that to make sure that no one shares information with the other. So that's why it is a bit hard from that perspective of mobile applications. So in simplicity, if you have multiple users on mobile, then you need different applications. I think you've seen it even with WhatsApp. You see, like WhatsApp, then there is WhatsApp sort of business, which is almost the same sort of application. You just change some settings in the system. Then you have WhatsApp Web, another independent sort of application. But we don't have a situation where you are a WhatsApp administrator, okay? You have WhatsApp administrator, and then what you access is completely different from what other users access. Like you have your own app, you log in, and then you access different options. And then you have other users also using the same app, logging in and accessing different options. No. If that is to happen, then you have different apps. You have one app, WhatsApp Administrator, independent app. I think that's WhatsApp for Business also. Then you have another app that everyone uses. So basically, I think that's what I wanted to mention at that point.
I think I get the whole idea. Thank you.
Hey, you're welcome. Then I think, let me also talk about this. So we have, when it comes to data, we have, so basically you usually collect data, and this can be qualitative or quantitative. And so the first step usually when you have data is to perform some analysis, right? So this could be EDA, that's exploratory data analysis, or you want to test some hypothesis. Well, so this is at the point, at a level of data analysis or data analytics. That's at that level. Of course, here you can go ahead and build some models, but mostly these are going to be linear. They're usually linear models. Y is equal to mx plus c. So mostly linear models. So you're still at a static level These are usually analytics models or statistics. Then you want to compare A and B, you want to check whether A causes B or the like, or ABCD causes E and the like. You keep adding until when you have a proper model. Then this is usually done. If you want to stop here, then you have usually small data. Maybe up to 500 records or more, depending on what you want. But up to, this is up to 500 records. Could be equal or greater. But then data can grow into big data. Big data these are records basically that can't be stored in the normal databases. The usual databases here we talk about now with your 700, with your 500 records, you can store in MySQL. You can store in, where do you guys usually store? Access or Excel. And well, there are those also who use Postgres, or and so on and so forth. But then when it comes to big data, it's hard to just store it in the usual databases. Okay. So the data becomes non-structured, or it can still be structured. Structured in the sense that you have name and blah, 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 organized in a proper way and then stored in, let's say, normalized sort of database. So when data becomes big data, of course, you can still build linear models as baseline models and the like. But now this introduces machine learning. So now you can build models. You can say, okay, with this large data I have, it is becoming hard to use statistical approaches. Why is it hard? Because the data is too much. I imagine you can have, let's say 1 million records. And with these 1 million records, you have, you could even have 60 data points. Okay, like from name, age, okay, 60 variables, if I'm to say. And if you want to look at all those independent variables and try to compare, of course, there is a lot of research you can do from that. Because if you have 60 variables, the possibilities are endless. But then, if you have these 60 variables and you are using statistical approaches, that means you're going to build different small models, or you're going to have 1 million hypotheses, and it's hard for you to identify the relationships. And if you try, you will even find that the features are too many. If you try to connect different variables, then the data becomes too much, the relationships in there. And so it becomes so hard for you to handle that type of data. But if you put it in a machine learning model, then the model can try to identify all those relationships. You can use, if you have 60 variables, you can use the 59 variables to predict one variable. And so many other things. So you can easily identify patterns using what? Machine learning. So machine learning can handle multiple or large or big relationships. Of course, you can go ahead and think about deep learning and the like, but that's not the point. So the point here is when you think about how you're going to store data, now you have to decide, am I going to use any machine learning support or not? Because if you're not going to use any machine learning support, then now you can store all your variables in a database. All variables can be stored in a database at this point. But then if you choose to use machine learning, then you might need to store only a few variables, okay? Store a few. Why? Because initially, to train this model, you need a lot of data from here, initially. So here, if the data increased to 1M, let's say 1 million records, you are trying to use, but of course you are not using everything for analysis. But then you can get this 1 million record and train the model. Again, the idea here is you want to predict something. So you want to say that the risk of getting malaria, yes, we know from weather to mosquitoes and all of that. So you might want to say, okay, instead of looking at the individual variables, and then maybe I calculate the risk, or I try to predict the risk based on those variables, you can train the model on all possible causes of malaria in a specific area. So once you train the model, now what you will have to do is you won't need to ask the user all those variables again. Okay, where do you stay? Do you use a mosquito net? What is the size of your family? How often do you wash the mosquito net? When do you treat it? What type of medicine do you use to treat it? You know, all those sorts of questions. All those are captured, both the question and answer, and then used to train the model. So next time when you're building an application with the model, now you won't have to ask many questions because the model has already learned. So what you need to do is just pick a few variables from the user, just a few variables. You could just say, okay, my model, I'm basing on all the history to predict the risk of what? Risk of getting malaria. So here you can just ask the user, just describe. You can just tell them to describe anything about where you stay. So in here, they can just one input, they can just type and say, I'm so and so, I stay here and I've been like this and blah, blah, blah. And then from there, the description is just sent to the model and the model gives the answer without having a lot to store. Or you can decide now to store this description in a database. You can decide to do that. But the reason why you're storing this is, let's say these are just, they could be just small descriptions. So you can still store them and go back to analytics if you want, or you can use them to improve the model. So all these approaches can work. But the point is, the amount of information you need to store when you don't have a machine learning model is not the same amount of information you need to store when you have a machine learning model. So those are decisions. These are things you might need to think about as you build your application. Yeah. So I think I've introduced you to machine learning now. So next, I'll talk about machine learning next week. So I might not repeat exactly these same things since we've talked about them already. I'll try to introduce some other approaches. So now I want to talk about our databases. So we usually have, let's say, I have an application here. This is app 1. And then I have app 2. So what happens is you have an SQLite database here. And you might also have an SQLite database here if you want. Then in between here, you have your content provider. So this app, let's say it's storing these are responses from patients. So you are just doing, we have a survey, we are collecting responses from patients, and then we are storing them in our SQLite database. Then here, we analyze patients' responses. So I'd like to think that this could be just the user app here, and this could be the data analytics app. So this is where we see the reports from, but here you have forms. So what happens in this case is, actually this SQLite database is not even needed. Okay, I won't rub that, but just assume that this is not needed. I've not rubbed. Anyway, so that means here, as we collect information, it's stored in the database here. And this database is owned by app one. So if we want app two to access the same database, then we write a content provider. Okay. So this content provider here is written when we are building this app. Okay. That's when we write that content provider. And this content provider usually has a unique name, what we call a URI. This is a universal resource identifier. So this name is what identifies this content provider. So app2, because app2 doesn't have an SQLite database to store the same information, the information is stored in app1. So app2 can utilize the content provider to access the information that was collected by app1. The way it does that is through the content provider. So with it, it might not need to have even the SQLite database. But just in case you decide, again, these are decisions from development and what you want to achieve. Again, if you decide to say that, oh, I want to store whatever I analyze in a database. Yeah? So you have analyzed, then you also decide to store this in an SQLite what? Database. This is your decision. So if you have results here, these are analyzed results, they can only be accessed on app2. If you want them also to be accessed on app1, then you also have to write another content provider from app2, and then app1 will access from that content provider. So basically that is the simple architecture. But you see, for you to do this, that means you have one phone. You're using the same phone to collect data. It has app1, and it's the same phone for analysis. You have app2. Now, should you require to go through the web, then in between here, in between here, so you have an exposed content provider, then you can push everything online. Or you might run away from all this, okay? Instead of struggling with the content providers and all that, you might run away and then you go on the web and use Firestore or Firebase, call it Firebase. So now the two apps are connecting through Firebase. So Firebase has a data store where all the information collected will be stored and even the analysis. But you can still have different apps whereby one app is used for collecting data, then you store on Firebase, that is the cloud. And then from there, you have app 2, which app 2 also connects through Firebase to access the same data store. And then it does its analytics. You can still push back the analytics online for app 1 to access if that's the plan, or you don't have to. Now, those are two models. Now, these are two apps again. Here I was just demonstrating content providers. But in case you just want to build one app, then you just build the app to handle everything. This one app can do the data collection and even the analysis. And then you display even the reports from this one application. You can still log in if you want. You can still log in and log out. Now the question here is, who are you building the app for? Because if you're doing the collection, analysis, and even reports, and this is a patient, it is one app. That means the patient will, or it will mean that many patients will enter information through the app and see each other's information because you're even providing analysis. Well, that's different. Or you can decide to say, okay, all this is for one patient. So let's say every day I record, this is to predict the risk of getting hypertension. Hypertension, if that's what you're trying to do. Then every day I can enter one record at a time, and with time, after maybe a month or so, you can do all this, analyze, give me a report, I can log in and everything. So that is also possible from that perspective. So think about exactly how you want to deliver your application and who is to use it. And remember that if it's one app, it's one kind of user. If they are allowed to access each other's information, okay, then that's a different case. But if not, then it is a personal app, independent. No one should what model are you going to use? What approach do you think you can use? There is no wrong or right answer. It's just an open discussion. So how do you think you're going to store your information? Do you need a content provider? Do you just need a database? Would you want to store on the cloud? I mean, from what I've discussed, what are your thoughts in relation to your application? You can unmute yourself and speak.
Yes, doctor. In accordance to our application, since most of the interactions will be, since it involves most of the interactions between different like doctors and clients, and as well utilizing artificial intelligence, whereby due to limited resources of the phone, it might be hard to host a model directly on a phone. I think we might need to utilize web in this case. But maybe you can guide us as well. But for me, that is what I think. Thank you.
Okay. Thank you. The rest, what do you think?
Dr. Pardon on the question.
Yeah, I was asking in relation to what we have discussed. What do you think about your application? What kind of model approach are you going to use to store your information? Would you need an SQLite database? Would you need a content provider? Would you need to build one app or two or three? Are you going to use the cloud? What do you think?
Yeah, I would continue. I would like to supplement on what Patrick has submitted. We are planning to have a cloud storage, so we are having our database in the cloud. That is a Firebase real-time database, which are going to be providing real-time data and real-time interaction, and as well as also saving the storage space on the phone. Since we are going to host or have our database or our data stored in the cloud, there we are trying to save some space and also have the real-time functionality whereby you can, because it is a teleconsultation, so real-time interaction would work well for this platform. So we are going to have our database in the cloud. I submit.
Okay. Thank you. No one else? It's sometimes, I think someone wants to say something. Stella? No? Okay. It's sometimes interesting. I find this so common. Most people who are involved in research, they always prefer storing the information locally first, and then uploading the information online later. But they have a copy of the information locally on their phone. And then for most people who are into business-related kind of work, they prefer to store the information on the cloud. And I guess the reason is most people who are doing research, they have to go to the field, and sometimes there is no network or there is no internet. So you just have this one app, you collect the information, then store it locally on the phone. And you can even just store the information in a text file. So instead of saving in a database, whenever people enter information, you store it in a text file on the phone. And then once they come in close to a network connection, the information is usually uploaded automatically without even someone bothering to push it online. So that is a model common for most research related kind of work. Then business wise, because you don't know exactly where your customers are, you don't know how to locate them so easily. So what we do is usually store the information on the cloud. So you can just download the app wherever you are, like any sort of app, even those you have used already. Then you log in using credentials from online, because that it's easier to authenticate you since we can't get in touch with you directly. So you just register from wherever you are, send your details, we validate, and then you start using the application. That is easy in the business world because we don't know where people are. So these decisions can be made from that perspective. Most of our work that we are doing here, let's think, if it's more research oriented, then you want to store information locally on the phone. But then if it involves people who are going to use your app and you can't access them one-on-one and the like, then you might want to go for cloud storage. So I think we will talk about cloud storage next week, not today. So my plan is that next week we look at basically machine learning, because that is our third week. And then the other last week we will be concluding. So but next week before machine learning, I think on Saturday, we'll talk about Flutter. Okay. We'll have some demonstration on how to use Flutter to build apps. So be ready to have that session. And then we'll talk about machine learning. Then you'll have a week to try and utilize it. But anyway, today let me try to complete content providers. I hope you have got the discussion more. Now today you are more enlightened about the databases and you know how important this sort of storage or database concept is. So we said they provide an interface for publishing data that will be consumed using content resolver, and they allow you to decouple the application components and okay, can it be a hybrid? Of course, hybrid is perfect if you have some resources. So you build the app, it stores your content locally on the phone, and then it also stores it online. So again, it depends on what you want to do. The question here is, why do you want to store locally and why do you want to store online? If you have answers to those questions, then you're good to go. And then Flutter, do we need to install any app? No, we don't. Yes, Flutter has some small API. If you want, you can check online and do some basic reading on how to activate the Flutter API in your Android Studio, but it doesn't take that much long. So you just have some small data for next week and the rest shouldn't be hard. Then the Dart SDK, the rest you'll use VS Code. Just the Dart SDK, the rest you will use. Oh, I'm seeing Joshua's response. Yes, that is also another language if someone wishes to focus on that. And yes, still, if someone wants to utilize VS Code, that's okay. But basically, we'll still build Flutter using Android Studio. So we might not use VS Code, but if you would wish to also share in that session about how you're using VS Code, Joshua, you're welcome. You don't have to be an expert, you just have to share something small that you know. And then some people might also find it very interesting there. I think VS Code has taken up the development world by storm. I see a lot of people now have brain for VS Code. So I welcome it as well. Yeah. So content providers, we are saying one, you just need to create a new content provider, extend the abstract content provider class. Like I talked about an abstract class in Java. It usually has methods, but these methods are not instantiated or built or expanded. And you're saying it's a good practice to include static database constants, especially for the columns or variables you want to collect. There, it's good to make them constants. A constant is the same the way you know it in mathematics. It doesn't change here. So that's what here is what we mean to create a content provider. You just extend the class content provider, and then you start implementing what we call the abstract methods. And that is one is onCreate for creation of the database. And then there was update, query update, delete, insert. These methods, please remember them as we are going to look at them more. So then you want to register your content provider, which is registered within the manifest. Again, if you remember, even for broadcast receivers, we registered them in the manifest, or we had two ways. You could register them in the manifest or directly in Java. Then you'll find something called the content URI. You'll find it's common. And you're saying the URI, which is basically the universal resource identifier, it's used for identification. That's why it's an identifier. So you can have multiple applications on the same phone with multiple content providers. The only way to identify a content provider for each of these applications is by use of a URI. And the URI comes from a class we call the content URIs. So I say this should include the name, so the structure of the URI. One, it has the name, and that name is usually for the whole content provider, or call it authority. Then it has a path or direction, and then a number, which is usually an ID. So an example is here. So you usually have, for web, okay, a website has a URL or universal resource locator, and that is the web address. And usually it starts with the word URL. Sorry, it starts with HTTP to define the protocol. And once you see HTTP, you know that this is a web address. Here we follow the same structure. But here, instead of HTTP, we say content to show that this is a content provider. Then this is usually the package name, because the package name is unique to every application. And then this last one is usually an identifier to specify whether you need all the records or you need a specific record. So a content provider URI must be unique to the provider, like we said. And we are saying that you can use the package name first. So there are two forms of this content URI. A request for all values, where you just specify the table, or a request for a specific record. So instead of retrieving all the information about patients, you might want a record of patients, of a specific patient whose ID is number 5. So because 5 is the identifier, if you're using phone numbers as identifiers, then here you can specify a specific phone number to get a specific record. Then we are saying it's a good practice to support access to your provider for both of these forms. That is You provide for both all records or one specific record. And we do that using what we call a URI matcher. Please remember, you have a content provider. We've talked about a URI for identification. And to access either one or all the records, we're using what we're calling a URI matcher. So this URI matcher handles single multiple query requests. And this is how it does it. So first you have the content provider defined. Then you have an identifier. You remember URI, where we said it starts with content. Then you have the path, or call it a package name. And then you append either to access all items or not. And this is how we are just instantiating the URI, okay? This URI that has been defined, called my URI, yeah, has been defined. So we define the URI here. This is the main class. And then we pass what we have defined. It's good enough. Joshua talked about pass yesterday. So you know what pass does. Pass basically tries to convert. So what we are trying to do here is get what we have identified as our identifier for the content provider here, and then convert it into the proper format called URI. And then this will be the reference. So anytime we call content underscore URI, we are referring to this, or access to all items. Then you have the database for creation, which we talked about already. So that means if you want to record all rows or a single row, you can use these numbers or these values by just passing a number at the end. Okay. For instance, here you have the URI matcher equals to that is instantiating the URI matcher. So at first there is no match. Second, all rows, as we said, all rows is represented by 1, and then a single row represented by 2. It's just an initialization. So once you call the matcher, because the matcher is going to match whether you're requesting for one record or multiple records. Its work is to match, as simple as that. So you add both URLs. Sorry, both URIs. One for accessing all rows and one for accessing a single row. And for a single row, it has an extra hash here. This hash is just a data placeholder, which placeholder is for this single row here, which single row was initially assigned to 2. So basically, that's the difference between the two. And then content providers expose. We talked about this. We said in Android, when you write the SQLite database, you have these methods. I don't remember. Do you guys remember seeing insert, delete, update, and query in SQLite? Class.
Yes, Doctor.
Do you remember seeing these methods in
Yes.
You did see them in content providers?
Yes,
Oh,
yes.
sorry. Not
In
content
SQLite.
provider. In
SQLite.
SQLite.
Yes.
Okay.
Yeah.
So anyway, thank you, Anthony. So they are coming back again in content providers, and they are the same methods. But the issue here is that we are just exposing them. So these methods are the interface used by the content provider to access the underlying data. The most common scenario is to use content provider to expose a private SQLite database, like we talked about. But you can also access any source of data within these methods. So we are saying given a URI, now we know how to construct URIs. And once you have this extra value, you're trying to access one specific record. But this whole URI, you can actually separate it. For example, if you want to check which you are writing an application to use a content provider, and let's say maybe you have multiple content providers in your application, and you might want to check which content provider you're using, and maybe you're basically interested in the authority, which authority we said is usually the package name, because the package name can tell you about the app that you're using. Or you might want to check whether you're retrieving all elements. Usually this is usually the table name for where data is being retrieved, and this is usually the value for a specific record that is being retrieved. So this one helps to break down the whole content URI to access the different sections of the URI. And the URI doesn't have to be a content provider. Even if it's HTTP, you can still check. So imagine you have web links, you have content providers, you have file transfer protocols, you have all those protocols that follow this sort of structure, and you want to check for how many are there in your program, then you can just break it down and check how many content providers you have in your code, or how many HTTPs you have, and so on and so forth. So then to create the content provider database, we are saying you can initialize the data source you plan to access through the content provider, a data source you plan to access through the content provider. And so that means you must utilize SQLite Open Helper. We saw it's the one used for creation of SQLite databases. And the structure still doesn't change, just on create, use MySQL Open Helper, and then the database name, and then the version of the database. And then you implement query and get type. We are saying content resolvers use these methods to access the underlying data without knowing its structure or implementation. So, like I said, we have the content provider there that it creates the database, exposes the methods, and then it also exposes these query and get type methods, and then they're all consumed by the content resolvers. So the most common scenario here is to use content providers provide access to the SQLite database, but with the methods you can access, but with these methods you can access any source of data, that is query and get type. These are other convenience classes. We talked about the URI matcher, and also there is an SQLite query builder, which is used as a convenient helper for performing row-based queries. So query is basically retrieving information from a database, and you have rows. So the query builder can help in that retrieval. And then the other last step is to do with the MIME types, all multipurpose internet email extension. And I'm saying this one, you can still override. I think I have a slide about, I have something about MIME. You can override the get type to understand, of course, to access the type of data that has been passed. We use get type to understand the type of data that has been passed. Even here, it's the same thing, query and get type. So if you query information from a table, then we must know what type of information we have queried. Is it text? Is it images? Is it audio? Is it video? That's what we mean by type. Or it could even be an email. So that's why we use get type. It's from after knowing the type of information that we can know how to handle it, allow the provider will understand how to handle the information. So that's why you're saying override the get type. And for a single item, this is the structure. And for all items, this is the structure. Remember now there are two. The first one was about retrieving information. But to retrieve the information, we said we needed to have an identifier for our content provider. So that identifier was starting with content, and we called it a URI, basically to identify our content provider. Now, this second one, this sort of link, or these two links you're seeing, these ones help us to identify the type of content that has been retrieved. Because remember, content provider, when you request information, you can request all information, all one record. So even when we know the type, to handle the type, we still need to specify what we are calling a get type, which now helps us to identify again whether you're retrieving one item or multiple items. And this is also the structure. Then the MIME type, defining content. This is multimedia something. I've forgotten it in full, but you can override again get type just as an example. We've explained this here, just providing an example. So get type, switch to the URI matcher to match depending on the URI that has been brought back. Again, the URIs can retrieve a single row or multiple rows. So if what is returned here is for a single row, then the type of data that will be handled will be handled by this URI matcher at this point. Okay. And if all rows have been returned, then this is what will be, sorry, this is the MIME type we'll be using, not the URI matcher. This is the MIME type. The URI matcher is here to check whether a single row or multiple rows have been returned. And then after deciding that, it picks accordingly. And then the content provider will know how to handle the information according to the type. Then transactions, so there we have been retrieving, but then we haven't talked a lot more about how to delete, insert, update information in the database. So you're saying to expose the methods delete, insert, and update on your content provider. You're implementing the corresponding methods. These methods are already written, so you will rarely change anything. And you're saying it's a good practice to call notify change, that is to handle any changes that have occurred between the database and the content provider. And then you have a content observer, which we are calling a class that receives callbacks for changes on content. And this you must override on change callback. So its work here is usually when you have an SQLite database and you have a content provider. When you add content in the SQLite database, the content provider must receive it. But also when it receives, because it is also holding some sort of temporary table, then it has to keep checking on the original SQLite database to see whether there are any changes. And that change or monitoring, okay, that change or monitoring is done by the content observer, okay? So, sorry, it's done by the notify change method. It's basically looking at how data is changing between the SQLite database and the content provider. And if there is any change, notify change will tell the content observer, and then the content observer will help the content provider to update the information as per the original table. Remember, here it's like you have a proxy. A simple logic here is, imagine when you are in Imbara and you have a friend wedding in Kampala. And there you have another friend who keeps giving you updates about how the event is going. This is the same structure. So you're here trying to access a database of the wedding, but you don't own the wedding. Your work is just to know what's going on. So someone else, a friend, keeps updating you. He keeps looking at what is happening there and then telling you, hey, now we are cutting the cake. Yeah? So the friend there, well, it's not physical. So the friend is your notified change. So his work is to check and then maybe go on the phone, which phone now can act as the content observer. And then he sends you a text. So the content observer delivers and gives you an update. So that's how the process works here. So these are just methods that are exposed. As you can see, this is delete, takes a URI, what is being deleted, and if there are any arguments. Remember, delete you say delete, then where are we deleting from? From a database. Okay, which database? Then we need to have the URI. The URI for a specific content provider, which content provider connects to an SQLite database. Then the string selection is, what are we deleting? Is it a first name, last name also? Then are there any arguments? Arguments like where A equals B, or where A is less or equal to B, or between this and that. So that's the basic structure. And then the rest is defined within here. From opening the database, then specifying the URI matcher, which now we know are either one row or multiple rows, then returning, because you query, then you return, is it one row or multiple rows, and then you notify if there are any changes. You see get context, dot get content resolver, dot notify change, and then you return the delete. So, because again, when a delete happens, we have to update. Insert, not so different. Again, insert is where we're inserting. We must specify where we are passing, that's the URI, and then we use the content values object. Content values class is the one that helps you or allows you to add information into an existing database. So again, to transact or send this information, you must first of all open the database, and then this just passes an empty content, column hack, and then we call the insert, okay, function, where we are saying DB, which is the database that we opened, dot insert, then MySQL open hopper dot database table, because this is the table you want to add information to, and this is like what we are trying to add, and then the values. And so if it's greater or less, greater than -1, that is if it's not 0, okay, so if it's from 0 and above, it's not a negative, then the rest will happen. So basically, this is just trying to transact by trying to insert all add information to a database, which is SQLite, but through a content provider. That was insert. This is update. Again, update is not so different from delete. And basically to use, we are saying the user can query and transact with the content provider through the content resolver class. There are some resources that you could check out if you're interested. We talked about the content resolver. I don't think I need to talk again about it. Yeah, the content resolver, its URIs, and the two forms. We have talked about all this. Querying, adding or updating. So this was just some sort of example on how that could be used. And maybe what I can only talk about is as you add information, is you can decide to add information just by calling insert, because insert helps to add information, or bulk insert if you have an array of content that you want to add. Yes, inserting new records, get the content resolver. We know what the content resolver does. I hope so. Then you create a new content values object, because it's the new values where we keep adding, like use the put method, column name value, and so many more. And then you have the URI. So you are trying to insert into or through the content resolver. And then here you're calling your content provider. That is here, they're using my provider as a reference, but we know the provider name has a URI. So if I say my provider.content URI, that means I already have a URI or an identifier for the content provider. And then we insert these new values. And this also, if you have an array of values, that is, if there are more than one values, then you can just use an array, as you can see here. And then the new rows here, we are using basically a bulk insert. That's why we are using an array. And so many columns here. So the array can handle one at a time, just loops through and then inserts our content automatically instead of one record at a time. Deleting, we talked about deleting, updating, all those are other examples. Oh, are there any questions? Okay, no question. Yeah. Question. Yeah, I know when we talk about content providers and SQLite databases, it's a bit crazy. There is a lot of small classes and small APIs that someone has to know. And so sometimes it makes it a bit weird and confusing. But it's not as confusing as someone might think. No, it's not. But there are also native content providers. Here, what we have been trying to look at is creating our own content provider and how you pass through it and all that. But there are many, like I mentioned yesterday. APIs already exist. You want to use the media store, for example, managing access to multimedia on your device, including audio, video, and images. Then you have to transact through a content provider. If you want to access video, audio from your phone, those that are already stored, or if you want to use the browser, so you can use a content provider that can read and modify browser and browser search history. Or the contacts, this one is also existing, retrieval of contacts from the, that's the contracts, we usually call it the contracts table. Calendar, you can create new events, delete or update existing calendar entries. Well, these are already existing content providers, so you don't have to write them again. You just use them. A call log, you want in your app to access the call log, who was called last, and what of you that's to do with call history. That is even including incoming and outgoing calls, missed calls, and call details, including the caller IDs and call duration. All that content can be accessed and you have it within your built application. So there are quite a number of resources. I believe they are still on there. Yes, they're I was just waiting for more people to join. All right. So we are almost done for today. Don't worry. So just going to share something small with you here. I'm trying to query something from this guy called ChatGPT. Unfortunately, I've not passed through the code it has shared. So, but I'm gonna let's try to pass through together. I think what's important is for you to see some of these concepts. The rest you can easily handle them. So I just asked it to, in case I have two apps. I have one app that owns the SQLite database, and I have one other that owns the content provider. So I asked it to generate some code. I can't trust this code because I have not run it, but at least I can trust that the core components that we have talked about since yesterday are going to be here. And these core components include the SQLite database, how it's structured, and then how the content provider comes in from the first application. And then when you have a second application, how does now the content provider pick content from that second application? So I'll just pass through. This is the manifest, which you basically are already familiar with. We can see the main activity here, and then we can see the content provider. And now the content provider, the authorities you see here is what identifies that content provider. If you remember the content URI had a part that is called authorities. So this, like I said before, this is usually the application package, package name. That's the package name usually. So that's how the content provider is registered. And its name is called user provider, but its ID is home.example.app1.provider. So please note that. The layout, and this one, I suggested that we just capture the name, phone, village, and maybe the photo path. And this is just a button for saving. Then this is main activity. So remember, we are still in app 1. So what happens in app 1? So in app 1, we need to create the database in SQLite. Then we need to capture this content. What identifies each of these is these names, ID names. So use those IDs to access each of these. ID, edit phone, edit village, edit photo, button save. So main activity is there. So we have edit texts accessed from the class edit text, which is already predefined. And then we also have a button accessed from the class button. Classes are identified with uppercase B. Then we're implementing on create as before, and then providing the layout. And in the layout, we try to access those different variables that we already defined up there. Then we're adding a listener to the button. So a user enters information here, and once they click on this button, we pick the listener. We pick the action by adding a listener. And then what we do with that after listening, we get the values. Remember, I talked about content values object. Sorry, the code doesn't have comments. I didn't ask that they add comments. You would have read comments anyway. But as you can see, to insert information in an SQL database, you transact through the class content called content values. That's why you see content values here. And then we are referring to that class, and then we keep calling put. Where are we putting? We are putting the information in the name column, and then we are getting the text and converting it to a string. That is from edit name. You see edit name here. It's the same here we access, and it's the same here defined as edit text, and it's the same defined in the UI here, edit name here. So you're picking the name. In Java, we just define the class, edit name. Then after that, we look for it here, where we access, we connect the UI to Java. Then whatever is put here, once someone presses submit, we add a listener. We pick what has been entered in that name section, we convert it to a string. Then we add it to a list of those values that are going to be inserted using the content values object. Then after all this is ready, we just define our URI. I don't know if it was defined earlier here. So we just define our URI and we are calling it result. So in this URI, we are getting a content resolver. Remember we said it's the one that consumes what the content provider has provided. And then we are calling insert. We are inserting through a URI. So if you remember the name of our content provider, this is the name. We called it authorities. So we are defining it and also defining the table name here. So this is the URI. What we are going to do here is we are doing everything in one step, but you can break down into different steps. Here, what is happening is we are converting our probable URI, and we are retrieving all content, as you can see. And after having our URI, we are inserting. Okay, what are we inserting? We are inserting content up here through a content resolver. And we are specifying what we are inserting through the values object, that is the content values object. So the values objects or the data to be inserted, then through the content provider, okay, then we are specifying that we are inserting, and then we are using the content resolver. And after that, we are making a toast by saying get this context, because you are in the main activity.java file, and then the result, we are just saying user saved, or if it doesn't work, we just say insert failed. So if it's null. So if there is a result, it will be user saved, and then if it fails, we'll just say insert failed. So that's basically it for Java. That one gets the content and then passes it through the content provider. But remember, with all this, we haven't created the database. This is just the first file structure. So then we have a user DB helper or the helper application. And this is also for the first application or the application where data is going to be inserted. So we are calling the class user_db helper and extends SQLite open helper. Remember, this SQLite open helper is the one that helps us to create a database. So we have the DB name as user_db and the version as the first version. Then we override or utilize, the user_db helper. This is the constructor. Okay, constructor just matches what has been instantiated usually with what has been instantiated with the real values. So anyway, we have the context, we have the DB name, which we have here. This is passed as now, then we have the version. So the name and version, the real values here are matched by the constructor here. And then, so we are overriding on create. remember we said this SQLite Open Helper has, you have to implement two methods, on create and on upgrade. So on create, we said to execute, we must call. So we read this query from inside out to make it easier for you. So first, we are saying we want to create a table. Okay. And this table is called users. It has an ID of type integer, and it's the primary key, and it's going to be auto-incremented. We have a name for type text, phone, type text, village, text, photo, also text, because we are storing a reference. Okay. So once to execute this, because we are not going to press enter for it to happen, we just call execute SQL. So once the code runs, this code will run by guide of that exec SQL. And then we call the other method on upgrade. Still, these two are part of SQLite Open Helper class that helps us to create the database and the tables where information is going to be inserted. Then we call upgrade, which takes the database, the old version and the new version. And so if the table exists, it will just drop it. Okay, the table you're creating is called users. So if it tries to create and it finds it existing, it will drop it. If you don't want it to be dropped, you can change this code. And then later it will create the table. So that means we have created a table, which table where we want to insert what? Our information. And someone can wonder, so how do the two connect? You see this table is called users, and you can see here how we are trying to retrieve information. We are retrieving all the information from there. Then we create a content provider. Still in the first application, you create the tables using SQLite data Open Helper function. Then you also create the provider, because we said another application cannot consume this data without the content provider. So the content provider is called user provider, and so it's here, public class user provider extends content provider. We say that's the first step. You must inherit from the content provider. Then you have the user DB helper to help create. This user DB helper is here. It's the one that helps to create the table. So we are calling it again. We are calling it here for execution. Then you have the authority, which we saw as the content provider authority. Then we have the content URI. So the content URI is built from the authority. You can see URI.parse content /+ all merge authority. So instead of typing all this, we are specifying it here. It's easy to maintain. And then you have the database name to access all the content from the database. Then in the content provider, again, there are methods we override. We talked about on create, insert, and query. These are the ones put here. But you can also think about delete, which are also here, delete and update, and then get type. These are the methods we talked about. So one is to create. So you call the database helper, which is here, DB helper. Which DB helper is the class defined here. So this is user DB helper. Okay, let's see. Oh, yes, it's the one. So because we declared it, it's a class, which is user DB helper. It's a class. Since it's a class here, that's user DB helper. Here to instantiate it, we just give it a name DB helper. So anytime we call it here, then we can instantiate it. If you don't want to go through all this, you can just say user DB helper equals new user DB helper, get context. So instantiate. When you run this code, it will create the database and also create the tables, the table. And then we override another method, insert. Since we are now creating a content provider, we must provide the URI, the content values that are going to be inserted. So SQL database, use the DB helper, open for writing, and then insert the table name and any values that are supposed to be inserted. And then you return the URI with append path. What you're returning basically, because you're inserting information, what you're returning is the URI and then the value of that specific ID. Then you have the query. For querying, we query through the cursor. Query is basically retrieval. So we query through the cursor class. So again, you specify the URI, projection. Those are usually the columns or variables you want, the selection, the string, arguments, if any, the sort order. So these are just parameters that are part of the query based on what you want to retrieve. Again, you open for reading and then you can retrieve all the information. The rest, this null dal is about this selection, arguments, and order. So each, if it's not there, then we just pass null. But if you wanted to retrieve specific content with specific conditions, then you would have a selection arguments like where A is equal to B, sort ascending. So then those would be variables that would keep passing here. So that's about querying. And then you also override delete. Okay. So what are you deleting? Again, you specify if you want that. This is an exposed method, but we possibly don't want to delete. If you want to update, you still pass that method. These are, here you might not need to change anything. They are already defined for you. And then getting the type. If you remember, we said they must understand the type of data that has been passed when data is retrieved. So that is about application one, where you have created the application where some information is going to be entered, and then you define how it's going to be entered through a content provider. Then you have defined how to create the table, what table and what database. Then you have also exposed or written the methods to use when you're dealing with a content provider. So anytime someone tries to use this sort of URI or the content provider identifier, then they can perform all this on your database. They can query, they can delete, they can update, and even insert information. So in application two, what's going to happen is one, yes, you define your manifest. This is unique to this app. Then you don't need a content provider defined here because you don't need it here. Then you have your activity main. The activity main, what's going to do is just to list the content that is entered in the app one. So main activity here, what is going to happen is you have the list view, you have an array adapter or array list. These are basically to view information. So they're not really necessarily part of the content provider also. So create, define the layout, find the view by ID. Then now you can see first we're identifying a URI, .parse, which URI. This, in the second application, this URI is the URI of the content provider. For app one, you can see when we're defining app one. So we have to transact through a content provider. Then the content resolver to query based on the URI and everything else. So we don't have any specific details because we are querying all the information. If you are querying a specific record, then we would put slash, then the specific record we want. If we had other conditions, then we would need to specify them. URI, then the specific columns, like maybe select first name, last name. The specific columns would have a variable here, where, and all that. So you're saying if cursor is not null and cursor dot move to first, because when you're querying information, you want to start from the first record. Okay, but if not, we saw how to traverse through the cursor. You can move to first, move to last, move to start, all those functions were there. I think I talked about them yesterday. But here we are saying if the cursor is not null, okay, that is if it's not empty, and so that means there is a record, then what do? First, get the name. So the cursor, get the string cursor dot what? Get column index name. Okay. Then second, get the phone number. Third, get the village, because this is the information that is stored in the what? Then add them to a list, because we want them to be outputted. Add them to the list, use concatenation, and then after, so you first retrieve this is the first column. You can see column index, this is the first column. Then from the first column, after everything has been retrieved, then you add a loop. So do retrieve these records, okay, while the cursor or while there's still some information, move to the second record, okay, then go back. So long as this condition is true, this will keep retrieving information. It will retrieve the first record. While there is still more information, it will move to next, move to the second record, then go back up to when there is still, if all information has been retrieved, then it will close. Then it will be added to an adapter, and then we should be able to see the information displayed as a list on the application. So basically, that's how the content providers and SQLite work together to share information. Okay, in case there is any question, you could ask. But if there is no question, then that means you guys have understood everything. Because the assumption is, yes, Emma. Okay. Yeah, and when you get those questions, sometimes when you're stuck, you could try to contact me, or you can ask Anthony. I'm sure Anthony is here. He will also be able to help, but where he can't, you can reach out to me. If I don't respond within a day, then remind me. Yeah. Okay. These other resources, some have. You could check out one of these resources if you're interested in now going deeper into the room database. I share with you. Feel free to visit that resource and then look at the room database and its structure, data access objects. And when you look at it, you will start now seeing the difference between what we have just talked about and how it does its work. So I'm going to share now what you guys going to explore. So let's just look at this, what you're going to do starting this afternoon. So of course, our deadline is always the following week. So you're saying you continue building on the Android health application you began of homework 1, but for this one, we want to implement some broadcast receivers, again, relevant to your application. I think we talked a lot about broadcast receivers yesterday. Then you want to integrate some data persistence mechanism. This is up to you. I've talked about content providers, I've talked about SQLite, and I would advise, again, based on your application, you can either do local storage or cloud-based storage. And then remember to generate a doc, a project documentation using Android Studio's documentation tools. These, you can just use Java doc. I think it's been even better. So this is just, it's just like 2-3 clicks. You don't have to write anything. So long as your code is done, you just generate this. So yes, look at broadcast receivers, and we talked about the different ways. Yesterday we talked about either it could be a system broadcast or it can be a custom broadcast app specific. I think I explained those yesterday. Yes, code sample, and then data persistence. I think we've also talked a lot about it. You can either use SQLite or Room, shared preferences. But this specifically should be related to the data you're collecting or the data you're going to use for machine learning. Okay, so shared preferences, I left them there temporarily, so long as you're handling data you're going to use for machine learning. Internal and external storage, again, you can explore that if you're interested in that. Go to Firebase or even other cloud backend services. Some of them have, honestly, I've never used them, but you guys could explore if you're interested in that. You might want to use Amazon Web Services, those of you who are okay with that, or even GCP, Google Cloud Services. And I don't know if anyone really knows how to use GCP. GCP or Google Cloud Services has been, or it's one of those web-based services or cloud-based services that are standing out. I think in the past I've struggled to get a developer who can use Google Cloud Services. I have struggled. Of course, I finally got one, but it was very, very hard. Most of them, they will say, oh, you see, I can do it. You're like, okay. Then you give them some few tasks. Then they start 1 week, 2 weeks, and they disappear. They say we give up. So Google Cloud Services is still something that is so wonderful. So I just suggested some cases. You could store a patient history or chat logs into the Room database. You could cache recent analytics results. If you have analytics you're doing, you can try to back up some logs or PDF reports into, that is for file storage. There is information that you don't want to lose. So you can store it in both a database and even a PDF or a text file. And you can always sync your data in real time, that is on Firebase. And for the documentation, use any of these. And so basically, if you should be able to build some PowerPoint presentation that would briefly takes us through the implementation of your concepts. And you're saying this should then transition us to your code and finally prototype. So next week as we talk, you can have some basic PowerPoint presentation. You don't need 20 slides, okay? No, I'm not looking for that. Just make sure that we understand. Even if there are few slides, the less the better, but make them so clear. Be as professional as you can. Don't just, I see I've met some people that usually just go to ChatGPT, pick things and then put in the slides. Of course, me, when I read content generated by ChatGPT, I can know. Yes. But the problem is not using ChatGPT. The problem is how you structure your work to make sure that we understand it and you don't confuse us. So, I expect the presentation will flow from these first few slides. Then from there, you move into how you implemented these concepts. Then from there, you do some small demonstration of your prototype. That should be enough. For now, you don't need a report. But if you have a document, the one you used for our first exercise, keep it. Just if there's something you want to add there, add it. Because at the end of it all, you will need a report for the final exam. And I intend that we build on the report you already have. So next week, I don't expect you to present a report. but please add what you have worked on this time. So this we are saying builds a report you had in homework 1. You can briefly add these concepts, but like I said, I don't expect to see this, but I'm just trying to guide you. Make sure that you add them. So for some references, if you need to read more, there is Android Jetpack. It can really open up your world to how you design better user interfaces. And this is Compose is also there. And the code labs that I've talked about today, you can follow them from there. Do I have any questions or anything that is not clear or something you want me to enlighten on further?
Yeah, yes, Doctor.
Yes, Anthony.
Mine's about the slides, the PowerPoint. Are we going to have, are we going to include even the previous work, or we are supposed to only include the work for today?
It would be good to have your previous work because it's a continuation. But for your previous work, as you come to present next week or share, you don't want to spend a lot of time there. Just to remind us that, hey guys, I'm working on ABCD. Last week we stopped here, and this week we have added what was required in such and such a way. Yeah, so it should be just to help us, remind us. Yeah.
Okay. Thank you, Doctor.
You're welcome. Any other question or inquiry? That is always expected. So the issue here you will have is because I have marked the first coursework, and that is what you presented yesterday. So if you change your idea, then next week you present work for the first week and work for the second week, because I'll need to mark you again. Yes. You're welcome. Any other? Okay. And it seems we are good. So we have just 4 minutes for this one to end. So I think today's lecture is done. We are going to stop there. So in the afternoon, please try to implement some of these concepts such that next week we move. We don't have to say, now you see, I didn't get enough time to implement because you are teaching for the whole weekend. No, you have the whole afternoon. Of course, I know it doesn't always work that way. The moment I say I'm done, then you are also done. You come back, you check next week. But it would be good to utilize the afternoon and try to build something and improve your application. So by the end of the course, you will be surprised about the type of app you will have. And still, if you want to utilize Kotlin, it is okay. You can use Kotlin, but if you do, then you have to explain and also implement similar features. And in case, guys, you see it's a master's. It's not a bachelor's degree. I might ask you to implement broadcast receivers, but along the way, you find a different implementation of broadcast receivers. They are broadcast receivers, but they have been improved, not the way I have taught them today or yesterday. It's okay, so long as you can be able to explain to us. Data persistence here, I have tried to limit it to some of these concepts. I have guided, and I'm calling them options. But you might want to use MySQL, okay? I'm not stopping you from using MySQL. The question is, what decision led you to using MySQL and why? Those are the kind of logical explanations I would be expecting if you chose to use MySQL. But I also don't expect the whole class to use MySQL. That because you know when someone uses MySQL, one group uses it and it works, then the other groups just extend from there. Eh? Please make sure that you make the right decisions according to your applications. Then, should you not choose to use Firebase or Firestore? That is also okay. Or should you use it just for one specific task and you use other databases? That is still fine. So you can use a combination of databases according to what you want to use to do. Right? So I'm not limiting you. I'm not saying that you should keep yourself on room database. I'm saying that this is what I recommend. But since it is a research kind of degree, it's a combination of PhD and bachelor's. So we do coursework, we do research. Then you have some leeway to explore and try to implement those concepts in your what? In your application. But if you do, make sure you can explain it to us and we understand. And it should be logical that, oh, actually, given this component, it's more suited to use such and such an approach. So for the materials, I'm going to share them with, I think, the president. Yes. Otherwise, have a wonderful afternoon and see you next weekend at 9. Welcome. Thank you.